Okay, so welcome everyone to Vedic Mathematics. Can you all hear me?
Yes, sir.
Yeah, good. So nice to everyone be here. Uh, so it's very fortunate that we are learning Vedic mathematics, right? So today I'm going to discuss one topic related to trigonometric angles, right? So generally, we all know means there are 6 trigonometric ratios and all these things, right? So sine, cosine, tangent, cotangent, secant, cosecant. So in this, and all the angles that we know. So here, basically, it is very specific. We are going to know the specific angles like 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. This all we know very well, right? So sine, cosine, tangent, right? Sine, cos, tan, cot, secant, cosecant. And all these values we know. Sine is 0, 1 by 2, 1 by root 2, and so on and so forth. Root 3 by 2. Right? So all these things we know. So beyond this, finding the angles, like if I'm going ahead, like 120 and so on and so forth, right? All these angles are, means converting them and writing them is little difficult. So we should know the basic rules and all, like whatever right now we are knowing these things, right? And then also we should know that. Can I go for the next one? So if I go for the next one, let us say we have 4 quadrants, right? So any difficulty, any question you can ask, no problem. So here we have first quadrant, second quadrant, third quadrant, fourth quadrant. And then we know that whenever any, means this is a trigonometric function, any function if I take, if it is 90 plus or minus theta, it will become cos, right? So whenever sine 90 and sine 270 plus or minus theta will become cos. And based on the quadrant, whether it is positive or negative, we will decide. So this much we know. But changing it becomes a little difficult. Whiteboard is not visible. How about all others? Is the whiteboard visible? Jyoti Pandya is saying that it is
Yes,
not
sir.
visible.
It is visible.
Yes, sir. Visible.
Yeah. So Jyoti Pandya, I request you to just close and open again, so you may find it, right? So, but when we are seeing sine 180 plus or minus theta and sine 360 plus or minus theta. So in these cases, this is sine only, right? So this is sine theta, this is also sine theta. So I'm not talking about plus or minus. So this can be in one quadrant, it may be plus or minus, right? So in both quadrant, this is anyhow plus cos theta only. 270 plus or minus means it is always a negative cos theta, correct? So this can be positive or negative, this can be positive or negative, because it can be here and here if I'm taking this one, and it can be here and here if I'm taking these ones, right? So if I come to this point, then it will be very easy for me to write the values, right? So rather than this, I'm more convenient about this because I'm not changing the sign, so that whenever any function is there, it will be easy for me. So there are multiple ways are there, but let us assume that right now we will stick to this method, 180 plus or minus theta and 360 plus or minus theta. It can be anything. It can be sine, cosine, tangent, cot, cotangent, anything it is. But basically, if I come back to here and here, this will be make my life more easier, right? So now let us deal with the 45 degrees first. So I hope till this point everyone is clear, right? All the quadrants and sine 180 minus plus, all these concepts are clear to everyone and everyone knows it, right?
Yes, sir.
రమేష్ సార్ అవును పాత బోర్డు ఒకటే కనిపిస్తుంది ఇక్కడ
You are
కనిపించట్లేదు.
not getting the new boards?
Yes, sir.
Okay. Anyhow, let me go to my white screen then. It is better. Yeah, I'll go to the whiteboard. I think then it will be more visible. Okay. So how about now? Can you see the new whiteboard where I'm writing sine?
Yes, sir.
Yeah. Okay. Now I'm not the host. Can you make me host, Charan, once?
సార్ చేయొచ్చు సార్, చేశాను.
Okay, right. Okay, good. So whenever I'm taking sine, cos, cosine functions and all, I'm giving an example with sine. You can replace it with anything, right? So my main aim is whatever the degrees are there. So I want to write as 180 minus 60 or 180 minus theta, 180 plus or minus theta or 360 plus or minus theta. So if I know their sine will remain sine, then it becomes more easy for me. So this is same as sine 60. So sine 60 is root 3 by 2. This much I know it. So but sine 120, because it is very near to 90, 180, it is very easy for us to do this thing, right? So, and all four quadrants for different things, like we generally remember all silver teacups or whatever, whichever way you remember. So basically sine function is positive here also, and here it is negative. So this much we know because 180 minus 60 in second quadrant. So we are getting sine 60, that is root 3 by 2, right? So now as I increase this number, it becomes difficult, right? So now let us see. So let us start with 0 degrees. So whenever the 0, 90 and all are there, it becomes easy for us, right? So whenever 0, 90 are there, so 0, 180, 360 and 90, 270, 540. Sorry, 450, correct? And 540 and so on so forth, right? These are all 0 degrees, these are all 9 degrees, 90 degrees. How do any number, how can we say that this is 90 degrees and this is 0 degrees? Actually not dividing it, right? So so that is the first difficulty, right? So if I'm writing 1440, is it 0 degrees, 90 degrees, or any other degrees? If we want to know this, right? So first let us simplify the simplest part of it, right? So here we are using the concept called digital root. And using these concepts we are going to use: digital root, divisibility by 4, and 9. So these three concepts we are going to use, and odd and even numbers. Right. So today morning, very good information is given by Mutyam Reddy garu regarding odd and even. So it is all about in our mind, right? So it is very important that how we are seeing the numbers. 3 means 3 tens are there, then becomes a even number, right? So 3 is an even. So anyhow, that is a different domain that we have seen, but odd and even numbers, right? So what you can observe here, can you see something related to this here? 0 and 90 degrees. If anything is given, sine 540 is given, immediately I will write 0. Why? Can anyone guess using these three concepts why 540 is 0? Right?
It is divisible by 9.
It is divisible by 9, first thing. And second thing, if I am writing sine 450, it is 90 degrees. So which is 1, right? It is 91. And this is 180 or 360, 0, right? So how can I say that this is 0 degrees or 180 is equal to 0? So how can I say using these three rules that this is 0 and this is 1?
So you already told us, sir, divisibility 4 you are using for finding the
Divisibility 4 as of now I'm not using. I'm using the digital root technique. And coming to that divisibility of 9 and coming to that odd and even numbers. So these three are connected. So in between, I'm asking questions. So if at all you feel comfortable, you can answer it. No problem. You can switch on your mic and you can answer it. Otherwise, you can mute yourself, right? So easily we can observe the digital root is in all these places, the digital root is 9. Correct? I hope everyone knows what is the digital root. In all these cases, the digital root is 9, right? So the digital root is nothing but adding of the numbers. Suppose 270 is there, 2 plus 7 plus 0, which is 9, right? If at all I'm having bigger numbers like 2790 is there. So then also 2 plus 7 plus 9 plus 0, which is 18. So which is 1 plus 8, which is 9. Or you can say whenever 9 is there, you cast out. So whatever remaining is 0. So that's how you can see the digital root of a number. I hope everyone is very clear with the digital root, how to calculate. If someone is not clear, then I will explain this technique. If everyone is clear, because I'm assuming that you people know idea about Vedic mathematics and something like digital roots. So if someone, even one person is there who is not understanding, surely I will explain it a little bit and then we can go ahead. Is this clear or anyone need any explanation?
Clear.
Sir, I'd need explain.
Okay, so digital root is the technique in Vedic mathematics to find a single digit number, right? Any numbers are there. Suppose if my number is 2790. So what I have to do is I will add the digits. And then whatever the number that I'm again getting, again some digits will be there. So I will add till I'm getting a single digit number. That is called the digital root. In this case, the digital root should be 9. Then we say that the number can be either 0 degrees or 90 degrees, right? So let us see that what is 0 degrees and what is 90 degrees and what is 270 degrees also, right? So here, because I'm taking a sine value or any value, because it is 90 and 270 means it is plus or minus 1 you will get, or 0 means there is no point, right? So this can be plus 1 and this will be minus 1. So we'll come to this a little ahead, but as of now, we observe that whenever we are getting a 9 number, right, it can be 0, 90, 180, 360. In all these cases, we will get for sine, we will get these values, right? For cos, it will be different. For cos, it will be 1, 0, minus 1, 0, 1. So like that, it will move on. But tan, every number, it has its own, according to the this thing, according to the quadrant, we will say that it is minus and plus, right? So first, let us see that whether it is 0 degrees or 90 degrees, and then we will come to it is 180, 270, 360, right? So first we identified that whether it is a 0 degrees or 90 degrees. How can we say that first 0 and 90? The digital root technique. The digital root technique, this is one way of finding the digital root. The other way of finding the digital root is whenever the numbers are adding to 9, we ignore that for the calculation. So 2 plus 7 is 9. I ignore for the calculation. So instead of 2 plus 7, 9, 9 plus 9, 18, I take directly 2 plus 7, 9, ignore, 9, ignore, and whatever the big number is there, I can come to this, right? So 0 and 90 is very clear. So 0 degrees, as I shown in the previous example, these are all even numbers, correct? And these are all odd numbers. So whenever the even number is there, that means related to 0 degrees. Whenever odd number is there, it is in the y-axis, right? 290, 270, 450. This is x-axis. So I hope till this one everyone is clear, right? So the digital root is nothing but you add the digits, you will get one single digit. Generally, whenever 9 is coming, we cancel out all 9s and we see that, right? So then it is the digital root is 9. So the digital root is 9 is clear. So digital root 9 means it is divisible by 9, right? It is divisible by 9, and then we have an even number, odd number. If it is odd number, then it is 90 or 270, something like that, right? I'm ignoring the 0. See, the last 0 I'm ignoring, and then observing the number is even or odd, right? So if it is an even number, it is 0 degrees. If it is an odd number, I'm seeing that is related to 90, 270, like that, right? I hope everyone is clear till this point. Now, we are using the divisibility by 4. We say that if at all it is divisible by 4, I'll come to here, right? So now, if the number is divisible by 4, after conforming with 9 and divisibility of 9 or digital root, right? So if it is odd means here, even means here, correct? Here means in this x-axis, even means in this x-axis. So if it is divisible by 4, then it is 0 degrees. If it is not divisible by 4, this number. I'm talking about only last 2 digits because the number last 2 digits, I can say that whether it is divisible by 4 or not, right? So it is just by observation. Any big number is there, just by observing the last 2 digits, and this is 0, then only it can be 90 and 180. Anyhow, most of the time this is 0. So if it is divisible or not, we say that if it is divisible by 4, then first if it is even, it is here. And if it is divisible by 4, then it is 0 degrees. If it is not divisible by 4, then it is 180 degrees, right? 180, 540, right? And so on and so forth. Is this concept clear? 180 and 360? Can somebody confirm?
Yes, sir, it is clear
Yes,
now.
sir. Please, sir.
Yeah.
Please.
So now we will move on to 90 and 270. Right? So this is odd number. Ignoring the zeros, these two are odd numbers, right? So this can be a 90 number or it can be a 270 number. Again, if I'm writing after 90, what number we will get? We will get 450. After this, what we will get? 630. Correct? Is everyone getting? So can anyone relate? Because I'm asking questions so that you can understand better. Huh? It is not that don't take it in other way. How can I relate this with 4? How can I relate this with 4 using the divisibility rule? So here I say that if it is an even number divisible by 4, then it is 0 degrees. Even number not divisible by 4, even number not divisible by 4, 18, 54, or not divisible by 4, then it is 180 degrees, right? And odd number divisible by 4 and odd number not divisible by 4, not divisible by 4. But I can relate this. I can, just by seeing the number, I can say that this is 90 degrees or 270 degrees. Can anyone guess? Using the divisibility of 4 only. Okay, using the remainders. What are the remainders here? Actually, if I say 0, 1, 2, 3, correct? If 2 is the remainder, then it is 180. 3 is the remainder, then it is 360. 4 is the 4 cannot be. 0 is the remainder, then it is 0 degrees or 360 degrees, right? Let us say example 2, 6, 5, 7, 2 plus 7, 6 plus 3, 5 plus 4. Suppose if this is the number, I want to say that whether this is 0 degrees, 90 degrees, 270 degrees, or 360 degrees. Can anyone guess what is this? Because this is even, first the digital root is 375354. The digital
This is
root is
from
9.
180.
That means it is multiple of 90s only, correct? Now I will use the digital divisibility by 4. 0, 1, 2, 3. So I will take 34 and I see that it is an even number. So it means when I'm dividing by 4, it is 2. Correct? So sorry, 90,
Yes, remainder is
180.
2.
Yeah, sorry.
1.
So here, right. So here this is 4. Sorry. So because that divisibility by 9, it works. Divisibility by 4, the remainder is 2. So it is 180 degrees. Is that clear?
Yes, sir. Yeah. According to the remainder, we need to find whether, of which angle it is.
Yeah, just this is my observation only.
Yes,
Vilokanam,
yes.
it is just observation, but I have to express in words, right? So if this big number is given, if I ask you to find the what is the angle for this, it is very difficult for us, right? Previously, no, without knowing this technique, it is very difficult for me, right? Generally, people will divide by 360 and keep dividing and then getting a half one and then seeing that whether it goes or not. So it is very difficult, right? So just by digital root technique, 9 divisibility, and digital root technique is 9 divisibility, and 4 divisibility, we know that which quadrant or which value it is, right? Is this clear? So
Yes, sir.
0 degrees, 90, 180, all things are solved.
Yes, it is solved. It is clear now.
So any number you take, any big number, it is very easy, right? 637946808. So let us cut it so that it will be easy for me, right? So yes. So if this is my number, let us say, right? So this is equal to 180. Immediately I'll say that. Correct? So easy. Wow, good. Right? So actually, this I have developed on my own only. So just I want to share with all of you, right? So I have not copied from anywhere. Maybe existing, but it is my own way of thinking the things, right? So is everyone clear? This big number, just by seeing, I say that this is 180, right? Suppose big number 7361 639729189 or 459. Okay. So this is odd and remainder is 1. So this is 90 degrees. Is everyone getting it?
Yes. Yeah.
Yes, sir.
Yeah. And it is
Interesting.
beautifully exact. Yes, absolutely. It is beautifully explained by you.
Yeah, thank you. Thank you very much. So 0, 90, 180, 270, 360 are clear for us, right? Suppose 271 example we will take. I'm writing randomly the numbers. I'm not just coming up with anything. Anyone can take any numbers, right? 6, 3, 5, 7, 2, 4. Now 3, 7 means in 4 table, we say that it's 27. Okay, this is the number. So immediately I know that 5, 4 is 9, 6, 3 is 9. So now I'm remaining with 2, 7. Anyhow, this is 9. But when I'm dividing with zeros, 4, I'm getting 3 as my remainder. So it will be 270 degrees. Because the remainder is 3, not because it is 27. When I'm dividing by 4, the remainder is 3. So that's how I'm getting 270. And previously we have seen 180 examples, right? So one by one we will solve, right? So good. So 0 and 90, we are very, very clear. Either it is sine, cosine, tan. You can put all other things, right? So I'm not going into it. Good, good, good. So now the easiest thing is 45 degrees. So either it can be 45, right? 135, right? 225, correct? Or it is 315, correct? So these four are possibilities. So, so how should I come to this? So 0 plus 45, 180 minus 45, 180 plus 45, 360 minus 45. So because we ignore 5, right? And then what we are going to do is here, because 5 means it must be a 45, but where it will come, I don't know. So either it is 360 plus 45 or 180 plus or minus 45. So I have to come to that, right? So I don't know. Just let us see this, and whether are we getting any idea behind this. This I'm deriving right now. I struggled a lot, but this, while teaching only, I'm getting this idea. Again, same previous technique that I have used. So whenever it is 5, I'm sure that it is 45 degrees, assuming, right? I'm talking about generally 45 degrees. We will come to even, we can derive it to 15 degrees and all, but that will keep it as little out of the scope as of now, right? So we are looking only 45 degrees. So 5 means 45. I don't know whether it is in the first quadrant, second quadrant, third quadrant, fourth quadrant. So how do I know whether it is in first quadrant or in first, second, third, fourth? How do I know whether this is the point, this is the point, this is the point, the point? Any guess? Already revealed the answer. Previously, whatever we did for 0, 90, 180, 270, 360, the same thing here also we are going to use. Ignoring the last digit, we are going to see that divisibility of 4, 0, 1, 2, 3. Similar technique we are going to use. Can anyone guess? Yes or no? I need answer input from students also. Is someone there?
Yes, sir.
How do I get this? Can anyone guess? No guess? Hey, same divisibility rule. 4
5,
means,
like 5,
4
and
means,
the remaining number by 4, we are getting remainder 0, 1, 2, 3.
yeah, correct. Very good, very good. So that's how we are getting this. Correct? Wow, very nice. New exploration. Very nice, very nice. Coming up with open mind. So I hope everyone is getting this, right? So let us take something like this. 2, 6, 5, 7, 3, 6, 3, 9, 7, 2, 9, 5, 4, 9. So 45, 45, 135. So, you write 45 or 135. Let us say if I'm writing something like this, right? So this is anyhow nines and all are there. So I'm ignoring this. So I'm only focusing on last 2 digits, right? So these are all nines. 2, 7, 9, 6, 3, 9, 5, 4, 9. 45 is remaining, but I don't know, right? So and this also I'm including it, right? So 4, 5 also 9. So that is different. But last digit I'm not including. Here 4 is there. And I'm seeing the divisibility of last 2 digits. Right? So the same number is there. 2, 6, 5, 7, 4, 3, 4, 5. Can anyone tell me what is the corresponding digits? Means I want the answer should be, you have to tell it is 45 degrees, 135 degrees, or 225, correct? And 315. Which one it will be? Means it is in the first quadrant, second quadrant, third quadrant, fourth quadrant. That is what I want, right? So can you tell me out of this, one is in first quadrant and other is in other quadrant? Can you tell me that where
Third
it
quadrant.
is?
Third quadrant.
225, sir. Third
The
quadrant.
second one or first one?
The second one in the third quadrant.
76. 7, 6, 6.
Second one is in the third quadrant, which is 45, means 45 degrees, third quadrant. That means 225 degrees, right?
Yes, sir, yes.
And this one?
First
This one,
quadrant. First quadrant.
Yes, it is in first quadrant, right? So those who are not speaking the answer, can please mute, right? Mute themselves so that the other class will not get disturbed. So yeah, I struggled a lot for this to come up this, but suddenly in this class only it revealed, right? So very thankful for the class. Yeah, say before also I come up with some other techniques, because not necessary that 45, it may be 15 degrees, 75 degrees, all others also possible. But as of now, we are confining it to 45. So because of 45, it is very easy for us, right? Now, same way can we do something to 30 and 60? No, now let us see for 30 now, right? So 30, 120, 210, 300 and 300. Correct? And so on and so forth when you are adding 390 and so on and so forth. Right? So now we want to know whether the number is 30 degrees or 120 degrees or 210 degrees or 300 degrees. That means in first quadrant, in second quadrant, in third quadrant, and in fourth quadrant. Correct? So now ignoring the zero, the rule is ignoring the zero, we'll find the digital root. So the digital root is 3, 3, 3, 3, 3. Always the digital root is 3. Correct? Any
Yes, sir.
number you take, if it is related to 30 degrees, That means the digital root will always be 3. Correct?
Yes, sir.
Okay. Now, this 3 is related to first quadrant, this 3 is related to second quadrant, this 3 is related to third quadrant, this 3 is related to fourth quadrant. So how do I know whether this is related to first quadrant, second quadrant, third quadrant, fourth quadrant? Right? So what I will do is, I will subtract the 3 from this. Right? So what I'll do is, I will do in the other way around. So whenever the digital root is 3, I subtract from the number. Or I will add the number. So here if 3 means, first I will see that this odd, this is also odd, right? So that's how it is. And this is also odd. So these are all 90 degrees and 270 degrees related to, correct? And this is 180, 360 related, correct? Are you
Yes, sir.
getting it?
Yes,
So
sir.
odd means it is 90 degrees. Odd, digital root is 3 means it is 270 degrees related, right? So now what I have to do is, here whenever it is an odd number, so I will subtract first. So if I am subtracting, I should get an even number, right? Or I will take the complement of 9 this, and normally if I subtract, whenever I'm taking the complement, means this is even, this is odd, correct? In that case, I will take the complement to this and add. So if, are you getting? I will add. Subtract. That means, let me clarify you, even getting little confused. So what I'm going to do is, whenever 30 is there, I subtract 3 from this, ignoring the last digit, anyhow that is 0. So I will subtract 3 here. Whenever it is odd and even, I will add complement of 3, which is 6. So here 2 plus 6 or 12 plus 6, I can say, right? Whenever it is odd, I subtract 21 minus 3. Whenever it is even, I will add 60. 30 plus 60. Are you getting this? Or any confusion? So what I'm doing, first observation is odd or odd even. If it is odd, then I subtract 3. If it is odd even, right, my digital root is 3 and the before digit, before to 0 is even number, then I will add 6. Is that clear? The observation.
Yes, sir.
Whenever it is odd, I will subtract 3 from the last tens and hundreds place. I will take and subtract 3. If it is odd and it is 3, correct? When if it is even, the last digit is even digit, then I will add 6. Correct? So adding 3, I will get this. This is divisible by 4 and this is divisible by, not divisible by 4. Are you getting? I will take little more example. So 30, 120, 210, 300. Correspondingly, if you take for let us say 1800 ke baad, 1830, 90 we are adding. So 1920, 2010, 2100. Whichever one you take, right? So first I will check the digital root. So the digital root for all these numbers is 3. Can everyone agree? Do everyone agree?
Yes, sir.
The digital root is 3. So I'm subtracting 3 from tens and hundreds place of the number if it is even. And if it is odd even, then I'm going to add 6. So let me change the color and write. So this means minus 30. I'm subtracting 30. I'm adding 60. I'm odd even, odd. So minus 30 and plus 60. So this is also the same thing. Whenever I'm taking 1830 minus 30, correct? Because this is also odd. 3 means odd. So if I'm getting odd digit means I will subtract. So this is 1800 plus 30, right? This is 1980 minus 60. This is 1990 plus 30. 1980, right? And then 2100 is 2160 minus 60. So don't worry about this big numbers and all. So forget about this. So this means 0 degrees. This means 0 degrees. So 0 minus 60. This is fourth quadrant. This is third quadrant. This is second quadrant. This is first quadrant. How I'm deciding that? If odd means I will subtract 30. Right? Subtract 30 and then we will get some number. Right? So when I am subtracting 30 means I'm adding 1800 to 30 means what I'm doing is 1830 minus 30 is this, plus 60 is 1980, plus 20 minus 30 is 1980, plus 60 is 2160. That's what I'm getting. So coming back to this number, correct? So once I'm subtracting 30 means focus on this only. Focus only on this area, right? Is everyone clear how I'm getting this? This area. Whatever the number is given, if it is odd, I will subtract 30. If it is even 30 means I will change it to 60 and add it. Correct? So now we are getting 1800 or last digit, you leave it anyhow, it is 0. So I'm not worried about the last digits also, right? Right. So now this is 80, this is 98, right? And this is also 98, 98, and this is 16, correct? So this means 0 plus 30. Plus 30 means always it is in the first quadrant. Divisible by 4, it is in the first quadrant. So plus 30. Not divisible by 4. So and minus means it is in the second quadrant. Not divisible by 4 plus is in the third quadrant. Means see 180 minus is here, 180 plus is here. 180, if you are taking out 0, this is not divisible by 4. Right? So any big number is given just by knowing that the last 2 digits. I can easily say that that number belongs to which quadrant and 30 degrees or 60 degrees. Because I want sine means only sine. I don't want cos. So because of that, I'm converting it to 180. Otherwise, we can deal it in a separate way. Right? So there are 2 ways to deal this. One is maintaining the same sign. Sign means sign only we are maintaining. And then we are seeing that plus or minus here. Right? So although it is a little confusion, I will take few more examples and try to explain it. How much time we have? Okay, 10 minutes only. So if this is clear, then we can go ahead, right? So let us take little more bigger number, right? So let us say 70 to 100 is divisible by 30, correct? So if I'm taking 7230 and 73240 plus 90. 745075. No, 110 we are adding. Sorry. I have not taken correctly. Let me erase this. So let me take little bigger numbers. 7230 is first number. Now I'm increasing one and decreasing this. Correct. So plus 90. Increasing one, decreasing this. Increasing one, decreasing this. So these are the angles, right? So my digital root is always 3. So because 3 is there, so what I'm doing here is whenever 3 means I'm subtracting 30 from this minus 3 here, and I'm getting 720. Right? So 720 means because I'm subtracting 30 means I have to add 30. So this is sine 30 degrees. Sine 7230 means sine 30 degrees. Right? So if I'm coming to this, because odd and even, so I add 60. So add 6. So 738. Not divisible. If here you are adding means subtracting, that means sine 60. And this is in second quadrant, because this is not divisible means, and adding means subtracting. So it is sine 60. Odd means minus 30 minus 3. It is 738. Again, 38 is not divisible by 4. If it is not divisible by 4, second quadrant, minus means 30, sine 30. But actually it is minus sine 30. Sine 7410 is same as minus sine 30. Because it is in the third quadrant. So because it is not divisible and subtracting 3. Subtracting 3 means here we are adding 3. So it is in third quadrant. Subtracting 3 means it is next quadrant. Adding means, see, subtracting means this. Adding means this. Subtracting means this. Adding means this. Correct? So if here 0 means adding 6. Adding 6 means 56. 56 is divisible by 4. Yes. Right? So it is plus means minus 60. That is in fourth quadrant. Fourth quadrant minus sine 60. So although it looks like little complex, but I'm very sure that compared to conventional method, this method is much more easy. What I'm doing, simply finding the digital root. If this and this are odd, then I'm subtracting it. If this and this are even, I'm adding, taking the complement and adding it. Complement of 9. 3 complement is 9. The digital root is 3. Taking complement as 6. Adding this 38. Checking 38 is divisible or not. And then I'm going whether it is a second quadrant or first quadrant. Right? So if it is plus means I have to subtract. So it is 180 minus 60. This plus means this minus 60. This minus means this is plus 180 plus 30. So this thing is very, 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 very important for us, right? Any big number you take, if at all my number is 54673, 5496397. Suppose this big number is there, whatever. So because this is 90 means that is a different way. If I'm changing the numbers, right, instead of 70 to this, you can take that big numbers. So generally we don't come across these big numbers, but even whatever 1440 is there or 1470 is there. So just by seeing this, we know this the digital root is what here? 3. Whenever the digital root is 3, if it is odd, you have to subtract and take the last 2 digits only. If it is divisible, because you are subtracting, you have to add. So it is 0 plus 30. Are you getting it? 1470 is my number because I'm getting a digital root. This is digital root. If this digit and this digit are odd, then I subtract 3 and check the divisibility. Correct? So if it is divisible means 0. If it is minus means here it is plus. So 30 degrees. 1470 is same as 30 degrees. Right? So whatever the rule, again I'm writing the rule. First finding digital root of the number. And then if it is odd, if the number is odd, then you subtract 30, right? Subtract 3 from the 0, anyhow you ignore, subtract 3 and check the divisibility by 4. Right? And then your answer is there. Right? For example, 1470 I'm taking, the digital root is 30. So because it is 30, so I subtract 3 from this. So last 2 digits are 44. So this is 0 plus 30 degrees. Suppose if I'm adding 90 to this, so what will happen? 1560. So 156, what is the digital root? 3 again. So because odd and even, I add 60. So add, and then I'm seeing only those 2 numbers. 62 is 180 minus 60. 180 minus 60, because this is not divisible by 4. If I'm taking the next number, 1650, again the digital root is 3. Odd means subtract. After subtracting, I'll get 62, not divisible. So 180 plus 30. If I'm taking 1740, right? So what is the digital root? 3, right? So this is even odd. So you have to add 6. So 74 plus 6 is 80. So this is 360 minus 60. So this is 360 minus 60. So sine minus 60 minus sine 60, you can say, right? So I hope everyone is clear with this concept, right? So adhering it to that time, same like 60 degrees also. For 60 degrees, what you have to do? Suppose what is 60 degrees? 60 plus 90, 150. 150 plus 90 is 240, 330. So if I'm getting all these times, 6 as my digital root, correct? 6 as my digital root. So when I'm getting 6 as my digital root, so even means I have to subtract. Even means I have to subtract 0 plus 60 degrees. Because 0 means divisible by 4. Odd even means I will add here, I will subtract 60. So here I'm adding 60. Here I will add 30. So 180 minus 30 I write. Why? Because I will add 30. I will add 3, 18. Because adding 3 means subtracting 3. 180 minus 30. So here even. This is even, this is even. So I subtract. Subtract means 180 plus 60. And then this 6, odd and even. So I will take 30 and add it. So 360 minus 30. So that's how I simplify any trigonometric angle. Just by seeing that, you can easily write. Can you mute yourself? Hanapriya, can you mute yourself? Okay, can you hear me, everyone? Any questions from this? My time is almost up, right? So within the limited time, I want to restrict myself. Yeah, 1 minute before. Anyhow, if at all any questions, I will take for 5 minutes and then we conclude this. Any questions from anyone? Do you find interesting, easy, difficult, not understanding? Hello.
Very nice, sir.
Yeah, good.
Innovative concept. I never thought such thing in trigonometry.
Yeah, come again, Jyoti Pandya.
Very innovative concept, sir. I have never
Yeah,
thought such
yeah.
in trigonometry.
Yeah, thank you, Jyoti. Right. So very interesting. Those who are dealing with the trigonometric allied angles and all, actually, I used to confuse a lot to get the angle. It took a lot of time for me to get the angle. If you see any of the members, right, any of the intermediate students or +1, +2 students, generally they struggle with this concept. Although this is a simple, very one simple concept, but to make it more easier, I think this is the easiest way that I found. If you find something else which is very simple, I'm very happy to know it and learn from anyone, right? So it is not that what I'm getting is very simple, but you have to understand the steps and apply the logic in a logical way. So once you have this, then it will be easy. I will see that I will send you some means quiz type of thing with the video so that you can attempt and then get more clarity on this concept. I will ask Sharon to forward my, I have not yet prepared. I will prepare the video, I will prepare the quizzy and I will send it to you. If you if you watch the quizzy and then solve the things, it becomes more easy. The concept will get more established, right? So I will simplify a little more and then take it. Yeah, and the first technique just now I have revealed where 0 degrees, 45 degrees, 90 degrees. So that is very beautiful. And similar to 30 and 60 also we can do something, but yeah, it's okay, fine. I can always come back to you. Anyhow, this is a learning forum where we can innovatively learn the things and go ahead, right? Thank you for giving me an opportunity, everyone. Really happy to share this idea to you all. Have a nice day.
Thank you so much, sir.
I'm stopping my sharing screen. Okay.
Yeah.
Thank you.
Yeah, welcome, sir. So thank you for participating, everyone. Yeah. So the next class. Actually, we are waiting for the madam.
Hello, sir.
Yeah, are you there, ma'am? Yeah, okay. Veena, yeah.
I'm already in the meeting, sir.
Thank you. Please.
Sir, can I get the permissions?
Yes.
Thank you, sir.
Ma'am, you can start now.
Yes, sir. I'm trying to share the screen. Sir,
Yes.
is my screen visible?
No, not yet. Veena Pranati.
Sir, actually, I have prepared a PowerPoint presentation, but
What is the problem?
I don't know why I'm unable. I'm unable to share the PowerPoint, sir. Like
Just
I'm
say-
using my
Yeah,
mobile.
first.
Just use the share screen. That's it. Below or above, there is this share screen option is there. So just click on that and just select the first one, screen.
Sir, there's this blank option popping out every time.
Are
Can
you
I
using mobile
rejoin?
phone or system?
Yeah, better once you drop out and rejoin.
Okay, sir.
Recording in progress.
Madam, are you using?
No, she logged out. She will log in again. Just wait for some time.
Yeah.
Hello, sir. Can I get the permissions now?
Yeah, yes, madam. Yeah. And just now I make you host, ma'am. Please share.
Okay, sir.
Madam, are you using mobile or desktop, laptop, anything?
I'm using mobile, sir.
So mobile, just you click on the screen sharing option. Before that, you have to open PPT in the background. Don't clear it. So after that, whenever you are clicking on the screen share, in the background apps will be open. Otherwise, you can use any PPT presentation app like UPS, something like that. You can share the tab. In the tab, you can open the PPT. Are you getting, ma'am? Pranuti ma'am, first click on the screen share. After that, share the any application with accessible the PowerPoint. After then you can open that PowerPoint so that it will be very easy. Yeah. So I am going to share Madam PPT right now. Okay. Just give me 2 minutes. Hello. Is it visible, ma'am?
Yes, sir. Yes, sir. Thank you, sir.
Welcome. Please, you can continue.
Good afternoon, everyone present here. This is Pranuti. I'm pursuing engineering first year right now. It's only because of my mentor, G. Suresh Babu sir, who has asked me to just join about the Vedic maths during my IKS internship 2022. What I've come across about the Vedic maths is how rich our Indian culture is. Like the background of the Vedic maths, when we try to go deep into our civilization, we know what exactly today is our modern technology was present the thousands and millennium back. So let us know about the Indian culture, like Indian. Let us know about the India, the place of origin of Vedic maths. Let me share few points about India before we start about the Vedic maths. Uh, might be knowing few names from India. The first satellite was sent in the name of Aryabhatta. I think you might be knowing who is Aryabhatta. Anyone?
He is the first Indian mathematician who discovered zero.
Yes, you're absolutely right. So in India, the maths is way of life. We see that maths is way of life. It's queen of science and technology. Like the mathematical breakdown which happened in India, it's only because of many people who are lots interested in maths. Vedas, which are the backbone of a culture and heritage, they talk about things which are far more scientific. Like as we come across the things like yoga, Ayurveda, these all are things which are far more advanced than today's civilization. Veda is a source of extraordinary knowledge, which is neither unscientific nor irrational dogma. Let us talk about India. India is one of the oldest civilizations in the world, spanning a period of more than 5,000 years, whose heart and soul lies in its rich culture, heritage, and tradition. The first nation to have cultivated science is India. The Indian civilization stood the test of time and has given the world yoga, Ayurveda, zero, countless discoveries and inventions, of which many theories and techniques discovered by the ancient India have strengthened the modern science and technology. The abundant cornucopia of this knowledge has been passed on to us by our great ancestors. It can be found that what became area of India and its Vedic culture was way ahead of time. Ancient Indian scholars like Baudhayana, Aryabhatta, Brahmagupta, Bhaskara, Madhava, Mahavira, they were pioneers of scientific thinking. They developed the methodologies that can be applied to resolve any modern day calculations with speed and accuracy. Let us see about the glimpse of some of the landmarks in ancient India. The first one is the mathematics in the ancient India. So next slide, please. Here we are seeing the two pictures, like the brick size of bricks, and how particularly like how well the city was built. The development of human civilization, as we see, is accompanied by development of maths. Do you all agree with me?
Yes,
Yeah.
ma'am.
Like we have seen from the prehistoric excavations like at Harappa and Mohenjo-daro, like other Indus Valley sites, archaeologists they have found the evidence of practical mathematics. Practical mathematics. The people of Indus Valley civilization made bricks whose dimensions were in proportion of 4:2:1, like the most favorable for the brick construction. They also used standardized system of weight based on the ratio 1/10, 1/20, 1/5, half, 1, 2, 5, 100, 200, 500 with the unit weight which is nearly equal to 28 grams. Indus Valley inhabitants also tried to standardize measurement of length to a high degree accuracy. Harappa geometry gave rise to Sulbha geometry in Vedic times, which laid foundation of circle geometry. We can see a flourished system of mathematics in day-to-day life and how we are aware of the concepts of shape, counting, numbers, measurement, and so on. Next, we see about the Vedic period and Sanskrit. Why Vedic period is so much related to Sanskrit? Mathematics in ancient India, almost all the Sanskrit pundits who were trained in Sanskrit language and literature, they possessed a common stock of knowledge called grammar and logic. Memorization of what is heard, like we hear something, we remember it and try to pass it to the next generations. In the same way, the ancient people, they they try to memorize what is heard. Through recitation played a major role in transmission of the text in ancient India. Memorization and recitation was used in transmit philosophical and literary works as well as on ritual and grammar. Modern scholars of ancient India, they have noted a remarkable achievement of the Indian Pandits who have preserved enormously bulky text orally for millennia. The Vedic period has mentions for the usage of large numbers because of ancient Sanskrit terminologies. We can see that we can see the use of mention of multiplies up to of 10 power 18, 10 power 55, 10 power 140. They are infrequent use in measurement of space and time. Sanskrit is just not a language, it is the voice of India's soul and wisdom. It is the link between our past and the present. Sanskrit is the language of knowledge and tradition of a country. Sanskrit literature is a great repository of knowledge encompassing every walk of life, be it science and technology, agriculture and sculpture, astronomy and architecture, medicine and metallurgy, mathematics and management, economics or ecology. We see a rich, vast heritage of India's hidden in the treasure house called Sanskrit. Sanskrit was a medium of communication, education, law, administration, trade, commerce, art, research, all modes of intellectual debates. It was the link language of Bharat. Did anyone of you heard about something called Katapayati Sutra?
Yeah,
What exactly did you hear about it? Like how the words were encoded in it?
not exactly, I know, but I seen somewhere.
Yeah, Katapayati Sutra is a method in which every letter is given a number. We see it's mentioned in Vishnu Sahasranamam. There is a small sloka called Sri Rama Rama Rameti Rame Rame Manorame Sahasranama Tatulyam Rama Nama Varanane. What this sloka exactly tells is that if you read Sri Rama 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 sloka 3 times, it is equal to reading the Vishnu Sahasranamam whole. Okay, so what exactly does that paragraph wants to convey is in Sri Rama Rama Rameti, Ra and Ma are given numbers. As we see, Ra is second letter. We know Ya, Ra, La, Va. Okay, did you understand? Ya,
Yes, yes,
Ra,
ma'am.
La, Va. Ra is the second number. Okay, and Pa, Pa, Ba, Ba, Ma is given the fifth number. Am I clear? Am I audible?
Yes, yes, ma'am.
So Ra is 2 and Ma is 5. So 2 into 5 is 10. Okay. So Rama means you are multiplying 10 into 10 into 10. So that is 1000. Vishnu Sahasranama means like 1000 names of Lord Vishnu. And in the one sloka, our ancient people have put it in such a beautiful way that if we read that one sloka, it is equal to reading the whole Vishnu Sahasranamam. So that was the power of the language called Sanskrit. Like how the words can be given numbers. How that with the help of numbers, like we know that every word we pronounce has some positive effect surrounding us. Like you speak good, you go to temple, you hear some good chants, you feel such a positive divine vibes around us. So in such a way that the Sanskrit texts have lots of impact on us. Like the methodology or grammar rules, we see that like we think Sanskrit is an ancient language, what it has to do with the present. But you're wrong. You're absolutely wrong. Because like I can say that this slide. Okay. So in today's economy, if we see the Sanskrit is more than ever before. I think few of you watched Interstellar movie. Did anyone?
I
Okay, there's this small part where the aircraft flies down, and they say that there's some Sanskrit text going in the movie. Did you observe? There's a mention about India and Sanskrit.
uh,
No?
no, I'm not
Uh,
recalling it.
Okay, so like how we can see in today's economy, we see Sanskrit is more than ever before to preserve, to bridge the ancient and the modern. In today's present 21st century, everything is about computer digitalization, or like the future robotics, AI, and ML. We can see that if one word you have to convey one word in English, yeah, like sometimes the word can be mispronounced or it can be misinterpreted or understood by the computer. But Sanskrit is not like that. A word a word called water, pani, it can be it can be told in many ways in such a way that even the computer can understand. It is like most advanced for the computer to understand. Sanskrit can be used as computer language in future. Maybe in the coming in the future, we can see that the methodologies of the grammar rules of ancient Indian grammarian Panini has stated so Astadhyayi helps the modern linguistic studies, phonetics, natural language processing. Like the importance of Sanskrit is much like very much larger than the what we see today. We think Sanskrit is just for marks, like we learn it for in just inter or something to score 100 on 100 in Sanskrit, but it's not like that. The value of Sanskrit, like it goes down so much that uh, most uh, even the most difficult things can be calculated using Sanskrit. Only the thing is, in the advanced, in the present, people have become so westernized that they think English is the best language. But as we see that our Indian culture has abundant knowledge already present in the Sanskrit text. One such thing comes from the Vedic maths. Even there's a mention about Vedic maths in most of the things, but because of invasions and all the things what we have in the books or in the sacred places are tarnished or erased away. Vedic maths, like the person here we saw that how people try to orally transmit it, like from one generation to other generation, from Guru Sishya Parampara. Like the teacher teaches to the student to the next student, and so on. In like that, we have come across one person who has written a book for us, like to get about what is Vedic maths, and that person. So next slide, please. And that person is the father of Vedic maths. The math is already present in India, but he has put it into the written form, and he is Bharati Krishna Tirthaji. He is the person who has documented all the things, like the background of the topic. We see what is Vedic maths. Vedic maths, or it's also called Veda Ganitam. Ganitam means maths in Sanskrit. Is an ancient technique used in Atharva Veda. We see there are 4 Vedas. Anyone? What are the 4?
Rigveda, Samaveda, Atharvana Veda, Yajurveda.
Yes, very good. There are 4 Vedas in which the background of the Vedic maths topic can be found in Atharva Veda. For simplified mathematical calculations, which it was rediscovered, means it's already present, but it was just not written because it was only transmitted from one person to other. But it was rediscovered and written by Bharati Krishna Tirthaji in the 19th and 20th century. In Vedic maths, what we see are 16 sutras and 13 subsutras. So sutra means a thread of knowledge. Like simple formula, like we can say A plus B is equal to C. We give it the formula some name. Like that, these sutras are also some formulas, like simple formulas. These sutras are a concise set of formulas that can be applied to solve even the most complicated calculations in an efficient and swift manner. Then we see the 16 sutras. Like, so next slide, please. Yeah, here we see the Vedic maths is an ancient system of mathematics that is unique technique of calculations based on simple rules and principles with which any mathematical problem with arithmetic, algebraic, geometry, or trigonometry can be solved. I think in the previous classes, you have some teachers who told about the trigonometry things and simple algebraic calculations, like how trigonometry can also be solved using the Vedic maths. So like knowingly, unknowingly, we use Vedic Sutra in every day of our technology. Like whenever we use, if we use in the programming language, if you're aware, we use loops, something called repetition of some things. In that, we use this thing called I is equal to 0, I less than equal to 1, I plus plus, or I minus minus. In the software programming, like that is what is Ekadikena Purvena. Ekadikena Purvena means which is one more than the like previous one, and Ekanyurena Purvena respectively. Likewise, many Vedic sutras are used in multiplied unit of computer. We see computer technology, like the basis of computer technology. Anyone, like what from the very much base of the computer technology? What is like how computer is operated? Anyone?
No.
Do you know about zeros and one?
Yeah.
Yeah, binary.
Yeah, binary. Like 0 and 1, these are the base of the computer. Like the without 0, can a computer run? No, it's absolutely no. So the credit goes to the Indian people who have invented 0. Credit goes to Aryabhatta.
Yes.
Like we see how advanced the people were even in those days. Like they built things because of which we are able to progress in the present. And maybe in future also, we may find lots of innovations. We might be hearing about something called Vaimanika Shastra, like the how airplanes and things were built in the ancient Indian. What are the metal compositions present? Like how can you make an airplane? How can you make a propeller? How can the airplane fly in which direction? Like many things are there, but we don't know. The thing is we don't know. Up to few decades, even the world does not know what is yoga. After, like in the recent, from after 2014, yoga is recognized internationally. Like how can many things can be cured with the help of yoga? And the same thing applies to Vedic maths also. This abundant this knowledge present in the Vedic maths, even the most complicated things can be solved using it. Like you may be asking why Vedic maths when we already have maths which are being taught in our school, when there's trigonometry taught in our school, when there's all the Pascal's triangle taught in the school. But we see that what knowledge was present in India, it was traveled to West. Even the Pascal's triangle, you know that word trigonometry has Indian origin. Trigonometricum. Have you heard it? Trigonometry.
Yes.
It's from India. There are many things as we proceed. We see everything has its roots in India, but it's almost spread in the West. Like why Vedic maths? We can use this all other techniques. Instead of those techniques, if we use Vedic maths, we can calculate maths much more faster. We can see people who do abacus. We can see people who do Vedic maths and a normal. When we compare all the persons, no Vedic maths person, he'll be able to solve it more faster than any other thing. In the coming slides, I'll show you one simple way in which Vedic maths and the contemporary method both are being solved using Python. It's a programming language. If you don't know, Python is a programming language in which like most of the computer software use. In Python, we can see what like time is very much important for us. Like time is money. Even if we operate our phone, immediately what we want to see is the phone starts as soon as we click the app. So behind that, we use something called the time complexity. Like how fast can we open an app, open the phone, like switch on, restart, and everything. So in that, we will see that um, difference of 0.10 seconds, the Vedic math sutra gives answer faster than the conventional method. So we can, sir, next slide, please. These are the 16 sutras. I think you might be aware of the sutras, which are already like thought, something like that. Are you aware of the 16 sutras?
Yes.
Okay, this 16 sutras and 13 upasutras. One sutra I want to take is the first one, Ekadikena Purvena. So next, yeah. See, Ekadikena Purvena, in this, it is one more than the previous one. Adikena refers to greater value when Purvena means preceding. So using this sutra, we can calculate the square of number ending with 5. Like let us take 25. In 25, numbers ending with 5, if we square the numbers, we'll get 25. So keep 25 aside, and 2 plus 2 plus 2 plus 1. So it's 2 plus 3. 2 and 3. 3 2s are 6. Are you understanding? It's
Yes, ma'am. Yes,
625. If you take another number, like I have taken example of 65. If we try to do the square of 65, it is 6 into 6 plus 1, which is 7. 6 into 7 is 42, and 5 5 is 25. And if you take for number 85, which is present, it's 8 into 9, because 8 into 8 plus 1 is 9. 8 9s are 72, and 5 square is 25. So if we join together 7 2 2 5, it's the answer. Like these are very simple techniques. In the seconds, we can we'll be able to calculate the what is the value of 25, what is the value of 35. Can anyone say what is the value of 95? Using this technique, Ekadikena Purvena Sutra.
90, 25.
9025.
Yes, exactly. Sir, next slide. I just want to tell few things about the what I've written is the Python code using Vedic maths technique. And you can see the time of execution of the above program is 0.001341. Sir, next slide, please. See, here the time of execution of this is 0.00157. Like you can spot the difference, how the contemporary, like the present method, which is thought, and the Vedic math sutra, how fast it can solve. Even our brain calculates the same. If you use if you use the conventional method and if you use the Vedic maths method, our brain quickly responds to it. Like from the above, we see the time complexity and execution of the two programs, one which is written as Vedic maths technique and the other present day. We can conclude that the Vedic math solve the problem in least amount of time. Like this is how Indians defined perfect in creating the answers with least time consumption and more perfection. If you go to all the sutras one after one, we try to see many different variations in it. Even the same sutra can be solved 20. Suppose if you take a number 95, 95 square can be solved with many sutras. Not it's not restricted to only one sutra. Sir, next slide. What are the applications of Vedic maths? Like the ancient Indian mathematics ensures continuity between various subtopics of mathematics. If you see one topic, it's related to other topic. If you learn, suppose let us take an example of building a house. When we are trying to build a house, we need bricks. We need something called cement. Like in how much quantity we need the cement. Everything, if it is everything is in correct proportion, the cement, the water, all the chemicals, then we can build a strong building. Like the basis of anything is maths. We can see this spider web. It's in like even though spiders don't know what is maths, they build a web which is exactly like beautifully done, like without any mathematical calculations. Honeybee's comb, we see the hexagonal shape, how they build is maths, everything is related to maths. If you talk about this, it can be said that ancient Indian mathematics and the present day, they go in hand, that maybe one day ancient Indian mathematics even crosses the present, the Western maths. Vedic maths can be easily mastered in short time if you try to learn. I'll take the case in my case. I would like to talk when I started learning Vedic maths. It's just 2 weeks before. Until then, I was not even aware of the Vedic maths. 2 weeks before, I got an internship from Indian Knowledge System by AICTE. During that time, Professor Suresh Babu sir, who is HOD in CBIT Hyderabad, he was my mentor. Um, During that time, what I learned is like how fast this can be solved. As we go on, keep increasing our classes, as we study the next and next, we try to use calculator, because our mind will not be in a position to do so many calculations fastly. We try to use calculator, but when we use Vedic maths or Vedic Ganita, we can actually calculate without using a calculator. It also, like, it's interesting compared to the regular mathematics. Through Vedic maths, the stigma associated with mathematics can be reduced. People see like maths is very boring subject. It's very tough. It's difficult to score in maths. We see people telling in IIT, JE exam that see maths is very difficult. You can't solve it. It's so time consuming. They make some stigma like associated with maths. It can be reduced if you learn Vedic maths as we proceed, like that addition, multiplication, geometry, trigonometry, the arithmetic and combinations, or permutations and combinations, the arithmetics, everything can be solved with the help of Vedic maths. The Vedic, it aids the holistic development of an individual. What maths teaches is in some situations, it's maths which help you to anticipate the future. You can say might be there's this thing called how much distance you have traveled. If you look back, like if not like really in the present, if you look back what is maths, and after learning Vedic maths, how you see maths is totally different. You won't have the fear that maths is something very difficult. You can enjoy the subject. You can try to learn things. You can try to explore explore the things. Why Vedic maths? Me being the first year of engineering, and I have chosen AIML as my specification. I would like to just give a short brief on why everyone has to learn Vedic maths. The source of theory of computing programming language can be found in Vedic Indian history. Like the concept of zero, which is the base of modern computation, was given to the world by Aryabhatta. Panini, and another Indian scholar whose work in synchronic linguistic, Boolean logic, and context-free grammar is largely used in today's AI, artificial intelligence, and machine learning. Vedic maths is used in digital image, cryptography, computer graphics, algorithm design, data analytic, machine learning, IoT, which is Internet of Things, digital image processing, which use deconvolution theorem and Fourier theorem, can be solved using Vedic Sutra of Nikilam Navada Charmam Dasta. Cryptography, which uses RSA algorithm, can be solved by Udvatiryakbyam, and so on. By using these Vedic maths techniques, we can reduce the time delay and complexity. Thank you everyone for giving me this opportunity. I think I'm not that so expertise in the Vedic maths thing, but I have tried to give my best from the knowledge which was shared to me by my sir. And I thank all the mentors for giving me this opportunity. Thank you.
Very informative, ma'am.